Hello, my name is Peter C. Hayward. I'm the setter of this cracking sudoku that I made as a special thanks to Cracking the Cryptic. Or cryptic, as I've just noticed that says. I've had a few people ask me if there is a logical path to solving this, or if you have to resort to bifurcation. There is a logical path, so I wanted to make a little video explaining what that is. First thing I'll mention is that the puzzle gets a lot easier if you make a list of all the letters and all the numbers that they can be. Once you do that, it'll be a little bit easier to solve. The other thing I'll tell you up front is that a lot of the solve revolves around this space right here. So if that's all you need to get started, go for it. But if you want to go ahead and see the full path intended, I will explain that to you now. So what do we know about this puzzle? Well, let's look at a few things. Firstly, we know that C is a little killer that hits all three of these. So the minimum these could be would be 1, 2, 3. And so that would make C equal to 6. So the very, very minimum value that C can have is 6. So let's wipe out everything below 6. A, we know that is a little killer along here, and these are the minimum things that you could enter in here, which would be 1, 2, 3, 4, 5. So the very minimum that A can equal is 5. So again, let's erase everything on A that is less than 5. What do we know about R? Well, R consists of at least 2 along a thing, along a little killer sum. So R cannot be 1 or 2, and K we know is equal to R plus another number, so K at a very, very minimum has to be 4. And that's if this was, say, 1, 2, and then this was 3, 1, something like that. That's the minimum values for all these spaces. What else do we know about this space? Well, we know that it has to be one of the 9 digits, and we know that it's not S, I, M, O, or N. So this space here has to be either C, R, A, or K. Now, it can't be R, because if it was R, then it would have to be R plus something equals R, and there's no zeros in Sudoku, so that would be nonsense. It can't be K, because K plus something equals R, but R plus something equals K, so you run into a whole paradox there. So we know that this space up here is either C or A. And we know from the work we did earlier that C and A are either 5, 6, 7, 8, or 9. So let's pencil those in. Those are the possible values for this space. 5, 6, 7, 8, or 9. Let's start with a 9. Could this be a 9? Well, if this is a 9, then the very minimum value you could have here is a 1. R would have to equal a 10, and we know that R is a single digit, so this can't be a 9. Can it be an 8? Again, that would give us R as a 9, which is nice, but then we'd run into trouble along this little killer. 9 plus something would have to equal K, and we know that K is a single digit, so this cannot be an 8. So we know that this is either 5, 6, or 7, and that tells us that R's minimum value is 6. So R can either be 6, 7, 8, or 9, and for reasons we just explained, R cannot be 9. So R is either 6, 7, or 8. So let's write those in, 6, 7, or 8. This then extends K. K can only be now 7, 8, or 9. Let's write those in as well, 7, 8, or 9. To get from 6, 7, or 8 to 7, 8, or 9, you have to add either 1, 2, or 3. And to get from 5, 6, or 7 to 6, 7, or 8, you have to add, again, either 1, 2, or 3. This is important because it means that in column 9, there are these 2 cells that are both either 1, 2, or 3. So let's see what happens if we make this cell 7. We know that the maximum R can be is 8, so that would make this a 1, and R would be 8. And then K would have to be 9. That's the very, very minimum value it could be. So it would need a 1. And now we have a problem because we've used 2 1s in column 9. So from that, we can deduce that this space here is not a 7. So it's either 5 or 6. Let's have a look at 6. If this space is 6, to get to R, we can't add 3 because that would make R too big. So this space here would have to be either 1 or 2, which would make R either 7 or 8. And now to get from R to K, that is 7 or 8 to one of these numbers, we would again have to use either 1 or 2. So now in column 9, we've used all of our 1s and 2s. So let's briefly revisit C here. This space here can't be 1 or 2, so it has to be 3 or higher. For now, let's just say it's 3. So along this little killer, which is these 4 squares here, 1, 2, 3, 4, we're going to enter some minimum values. So the minimum value this one would be 3. The minimum value we could get here in these 2 squares would be a 1, 3 pair. Why a 1, 3 pair? Because whatever we use here, whether it's a 1 or a 2, we can't use it in either of these two squares. So let's just say this is, a 2, and that this is a 1, 3 pair. So you'll see here that C now, at the very minimum, has to be 1, 2, 3, 4, 5, 6, 7. So C has gotten quite large. So this space, which we know is a 6 now, can't be C. So in this situation, where this is a 6, it has to be an A. What's more, if you look at this, no matter what you add to this, if you add 6 plus 1 to get 7 down here, and then 7 plus 2, if you do 6 plus 2 and then 8 plus 1, you'll see that no matter what you do here, K is always a 9. So in the situation where this is a 6, we know that it's an A and that K is a 9. If K is a 9, C can't be a 9, C has to be an 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. So M would have to be 1 in that situation. So let's put a 1 up here. Now, let's look at this little killer. If A is 6 and this space here is a 1, then we know for a fact that this has to be a 2, and that these must all be minimum values to get to 6. So 1, 2, 3, 4, 5, 6. However, over here, we've seen that we've used a 2. So this would have to be a 1, this would be a 2, this would be a 1. But now we have a problem, because both of these spaces are 1. So in the situation where this is a 6 and this is a 2, we have a big problem. So let's unwind all of that. Okay, you ask, what if we don't make this a 2? What if we make this a 1? If this is a 1, then these have to be 2, 3, 2, 3. And we've immediately broken the puzzle because we've got 3, 4, 5, 6, 7, 8, 9. And we already showed here that in the situation where this is a 6, this has to be a 9. So C can't also be 9. So no matter what you do here, you cannot make this space a 6. This space has to be a 5. And as soon as you make this space a 5, we know that it can't be a C, because C does not have 5 as an option because of this little killer up here. So if this is a 5, which we just proved that it is, we also know that it's A, and that makes A into 5. So let's put that in. So we have our first digit in the grid. A is 5. What does that tell us? Well, let's get rid of all these other possible 5s. Get out of here, 5s. No one likes you. Okay, so A is 5. Great. What does that mean for the other digits? Well, to begin with, A being 5 means that these over here, this little killer, is the minimum digits. So this is 1, 1, 2, 1. And a few of these numbers will see other numbers. This one sees the S, so now we know that S is not 1. But more importantly, this one sees the M, so now we know that M is not 1. And in fact, if you want to, you can go through and work out that M has a minimum value of, a maximum value of 4, because if this was a 6, then the minimum you could put in here would be that, and then C has to be greater than 9. So M actually has to be either 2, 3, or 4. So let's write those in, 2, 3, or 4, 2, 3, or 4. Now let's have a look at C, because this space and this space are both seeing 1s now. So let's look at this space now. What if this was a 1? Well, then the minimum these could be would be 2, 3, and 2, 3. We already know the minimum these can be is 2 and 2. So that would make C 9, because that's 2 plus 5 plus 2. And if you look at column 9, you'll see we have a 1 and we have a 2, so that would make R equal 8. If R equals 8 and this equals 1, then K equals 9 as well. So that causes a bit of a contradiction there because we have 2 9s. So from that, we can tell that this space cannot be a 1. If this can't be a 1, then can R be an 8? 8 plus 2 or 3 takes us too high, so we know now that R is not an 8. Get out of here, 8. If R can't be an 8, this can't be a 3. So R has to be either 6 or 7. Let's have a look and see what happens if R is 7. If R is 7, this has to be 2, because 7 plus 3 would be too high. If that's a 2, then this is a 1, and now we get 5 and 1 is 6, which we know that R is 7. That's what we started with. So if R is 7, we run into an immediate contradiction. And that gives us r equals 6, and we have our second digit. Once we know that r is 6, we know that this is a 1. 6 plus 2 or 3 has to be either 8 or 9, so we know that k can't be 7. And now we want to revisit the little killer up here, because if you have a look carefully, you'll see that m can't be 1, because there's a 1 here that's blocking it. Along this row, this space can't be a 1, and along this column, this space can't be a 1. So there's no 1 in C. Over 3 digits, the minimum you could have there would be 2, 3, 4, and that equals 9. So now we immediately have our next digit, C is equal to 9. And just by process of elimination, that makes k equal to 8. Once we know that k is 8, this space here has to be a 2. That unwinds over here into 1 and 2. C equals 9, so we can fill that in immediately as 2 plus 7 is 9. K is 8, so there's another 7 there. A is 5, so I'm just going to go and fill those in around the grid. R is 6, and just normal Sudoku will show you that 2's can't be here or here, so this space here has to be a 2, which is conveniently our M, giving us another digit. M is 2, and we have a 3, 4 pair here. Once we have a 3, 4 pair, we know that I and S, neither of those can be 3 or 4. So I and S can't be 3, 4. They also can't be 5, 6, 8, or 9. Or 2, because that's our M. So we get a 1, 7 pair. And process of elimination tells us that O and N, 3 and 4. S we can immediately unwind. S is 7. I is 1, which is a coincidence. I didn't do that deliberately, giving us 2 more digits. O and N we know are 3 and 4 in some order. And now let's look at these killer cages. There's a lot of normal Sudoku you can do at this point, but I'm going to skip it. R here is 6, so these two cages need to add up to 6. However, they can't use a 3 or a 4, which means the only thing left is 1 and 5. So we know these are a 1, 5 pair. The 5 here immediately unwinds them, so we have 1 here, 5 here. This C cage needs to add up to 9. With a 3 or a 4 here, this could be either a 5 or a 6, but we just placed a 5, so we know for sure that this is a 6, this is a 3, this is a 4. Normal Sudoku tells us that none of these spaces can be a 1, so there has to be a 1 in one of these two. And now let's look at this sum down here. This little killer we know has to add to 9. These can be at the very minimum 1, 3, 1, 3. This one at the minimum can be 3, because there's already a 1 and a 2 in the column. 3 plus 2 is 5, plus 4, so we know that that's the answer, and this 1 here can unwind these, so that's actually a 3, that's a 1, and that gives us another pair of 1s here, because we know, this is basically an X-wing, we know that either these two are 1s or that these two are 1s. Either way, there will be a 1 in the A cage, which immediately tells us that the A cage must, in fact, be a 1-4 pair, because it has to add up to 5. And from there, it really is just normal Sudoku, which I'm not going to show in the video, A, because I'm terrible at it, and B, because if you can't do normal Sudoku at this point, this is probably a too hard a puzzle for you. Hopefully you enjoyed that, and it showed you that there is in fact a logical path. It's a very, very precise logical path, but that's what I wanted to make. I wanted to try one with a logical path, and I did. Thanks for watching. You can check out my Sudokus at peterchayward.com/sudoku.html. There's a link in the little bottom bar, and this is my first time explaining something. It's much, much harder than it looks, and I probably won't do this again anytime soon, so I hope you enjoyed it. Bye!